100%. Yeah, I think that one point that's really important as well that sometimes gets forgotten is that, like, this stuff, when you're looking at things from a real technical depth, if for example we went for a really specific, highly technical, like maybe even esoteric approach to solving a problem that took a lot of work to begin with, let's say 6 weeks or more worth of development work with a real research focus on trying to solve a problem, like with our hypothesis as to how we would solve the problem. And maybe the problem's like a really high value business problem. Maybe this would solve the product. Maybe it's delivering something at like 1x, and then this way of solving the problem, if we got it right, would make it 10x, and like it would change the landscape of how these problems are being solved. One thing that doesn't really get spoke about is that stuff in data science, there's a real uncertainty as to whether anything's going to work before you get into the weeds. A lot of the time, there's a real, I say non-zero, there's a pretty high chance sometimes that no matter what research work we do to try and, limitations on the data, limitations on the methodologies that we're going to be able to employ within the confines of the resources that we have, even limitations on the skill set of the team that are working on it, mean that some things aren't necessarily possible, and that might not even be obvious until way into the process. I mean, it might be weeks and weeks and weeks before we've gathered enough information to then say, okay, this is too hard, we can't do this. And that, see, going back to the point you made about agile software that you're talking about in the Q&A, that's a real challenge when you try and integrate data science into agile methodologies, is because if you're looking at things like building sprints and working in Scrum, a lot of the real valuable aspects of being able to plan and coordinate software development using those kinds of tools is by providing at least benchmark estimates as to how process, task A, B, and C are going to take, how long that will take a team of 5 engineers to work on. Now, I'm not saying that the software engineers have got all this sorted. Like, software estimation is notoriously difficult to do, but on that kind of like bed of sand, data science estimation is even more difficult to do because of the inherent uncertainty in the processes that we go through to solve the problems. Like building an API can take longer than expected because of unforeseen product requirements, but building like a machine learning model to sit inside that API can take even longer because we're not even sure we have the resources to build everything in the first place from a data perspective or expertise perspective. Whereas building an API is kind of, we've been doing this for a long time now. We've got ways of doing that that we understand how it's done. So it makes it really, that's another reason why we should be biased away from the more complicated kind of approaches up front, because we don't even know necessarily if taking a really strong hypothesis about how we'll solve a problem with a really specific, detailed, and technically challenging methodology will actually work in the first place.
Yeah, no, that is interesting. So I guess there's a few ways that this can break down. And I think it bears reiteration that effectively you can do a lot of work on a data science project and it literally comes to nothing. And the problem with that is obviously the resources are wasted. And at most you might be able to say, well, we now have identified that this comes to nothing, and that's a problem, and therefore we're going to add more, we're going to throw more good money after the bad to build what would be needed to make this work. And so some of the challenges are like, because I don't think people always appreciate this, where there might be a fundamental disconnect between the data you have and the information you need.
Yes.
And so like if you're trying to use that predictively, if there's a fundamental disconnect between what you have as your predictors, your X's, and what you're trying to predict, your Y. And that it's not just whether or not it exists, but whether it's strong enough to be worth your time and to be low variance enough and things like that, such that you can do something with it. So, and I think that it's, you can't tell that deductively. It's an inductive process. It's also prospective as well. It's highly prospective. And when you compare that to something like, well, you deliver a dashboard that's much quicker, and is also going to generate new hypotheses. So the other thing that it does is this brings up, instead of basically trying to say, I'm going to be the one processor on hypothesis generation, you're essentially bringing this, you're parallelizing the capacity to generate hypotheses, which then means that effectively they can bring up things. And one of the, are you satisfied with that? Because if so, then I'll move over to the next bit, sort of the good news, if you will, where you can
I think that's a good summary as to kind of like where the challenges are for dealing with like these kinds of projects, really.
Mm-hmm. And also, they can have immense mission creep. So the risk of mission creep is in all of these things.
I mean, 100% mission creep is, I think, especially in areas where there's a lot of, I mean, everybody who works in industry will have had an experience of trying to, like, the value of doing this kind of work doesn't need to be communicated to a lot of savvy, let's say, project or product managers or product owners. But the limitations as to what can be done definitely needs to be explained. So you often get very excitable product owners who work in large software teams who would be like, well, let's apply this really kind of like vogue technique to this particular problem, and then this will solve all the product problems that we have. And it's the understanding that needs to be kind of hammered home that it's just really difficult to do a lot of the time, and kind of managing expectations on that front is often like a really important part of the kind of collaborative process between people who are in the data science and machine learning side and folks who are from larger parts of the business as well.